today's video, we will be discussing a topic about temperature scale. When does F equals C? Or for what values will the temperature be the same for both of the units, degree Fahrenheit and degree Celsius? As we all know, Celsius is the most commonly used unit in temperature readings, be it in hospitals or in weather forecast. However, Fahrenheit is also famous in some parts of the world, especially the US. That's why we cannot just simply ignore and neglect the relation and conversion of this unit to degrees Celsius. There are a number of ways to solve the above problem, like finding out the direct relation between Celsius and Fahrenheit. That is, if you know and remember the conversion formula for degree Celsius and degree Fahrenheit. But what if we are totally not aware of those things? Like for instance, this problem is given as an exam and we are totally restricted to use the access of Google or those conversion formulas. So what we are left with are the basic informations, like the freezing point of water, which is 0 degrees Celsius and equivalent to 32 F, and the boiling point of water in degrees Celsius as 100, which is also equivalent to 212 F. From here, we will make an assumption somewhere on both the scales, C and F, that there's a certain point wherein the reading will be of the same value. So we assume a variable x for this degree Celsius, which is also the same x to the degree Fahrenheit scale. Then we can make use of ratio and proportion, since both of these are directly proportional with each other. Means as Celsius increases, Fahrenheit also increases. We arrive at an equation x minus 0 over 100 minus 0 equals x minus 32 over 212 minus 32. So solving these equations, solving for the x, which is the same for both degree Celsius and degree Fahrenheit, we get negative 40. Since this is ratio and proportion, we can even set up a different equation for having ratios, different ratios and proportion for both the C and F, and still get the same value, negative 40. If you notice, we arrive at a negative value which is supposed to be below 0, and our assumption place for the x is somewhere in between 0 and 100. This doesn't matter actually. We can even place the assumed position for x above the 100 degrees Celsius mark or 212 degree Fahrenheit mark, and the arrived equation will still result in a negative 40 value, because it means that only at this point the temperature for Celsius and Fahrenheit are the same. Another way of dealing with this is setting up an equation with two distinct variables. It's mostly the same as what we have set up earlier, having x as an only variable, but for this case we now have two distinct variable, which is we represent as C and F, and we arrive at this equation C minus 0 over 100 minus 0 equals to F minus 32 over 212 minus 32. And solving for the value of C in terms of F, we get C equals 5 over 9 F minus 32. We can substitute F with C, since our assumption is that C and F are of the same value at this point, and we get also negative 40. the same thing as what is shown on the right hand side, wherein we solve first degree Fahrenheit as a function of Celsius, and also we arrive at the same value, -40. So I guess we have answered the question for what temperature the values for C and F are the same, and we're also able to find out and derive the formulas for Celsius in terms of Fahrenheit and vice versa. Now I would like to include this some sort of additional information, since this time of pandemic our body temperatures are being checked whenever we go inside the mall or in crowded areas, or some random personal check with our relatives, just to ensure our safety from and to other people as well. We'll try to tabulate the values for C from 0 to 100, since we know the formula for Celsius in terms of Fahrenheit and of Fahrenheit in terms of Celsius. We can just easily get the equivalent degree Fahrenheit values for each values in Celsius. We even extended the values of C to negative numbers, just to check also that what we got earlier on this exercise, that the value for C at -40 is the same as the value in degree Fahrenheit. So now we'll try to squeeze in some values in the column Celsius related to our body temperature. Maybe we'll start from 36, in between 36 and 40, so we can be more familiar with the equivalent values in Fahrenheit. So in general, what we consider as a normal body temperature of a person is at 37 degrees Celsius, which is equivalent to 98.6 F. And this normal temperature ranges from 36 to 37.5, depending also on the body's location. And the critical ones are the one that is highlighted in red, starting from 39 to 41. And this range in Fahrenheit is from 102 to 105. So we should be alarmed once we got a record of a clinical thermometer ranging from 102 to 105. And of course, we can always verify and consult Google as a last resort for quick conversion of these values in degrees Celsius. So these are just for quick guidance, quick remembering of values in terms of Fahrenheit, in case that your thermometer readings are in Fahrenheit. Now we will try to graph both the Celsius and the Fahrenheit in a Cartesian plane. I am using this Geogebra apps graphing calculator. I'll be posting the link of this in the description below. So we'll assign the variable y as Celsius that depends on Fahrenheit x value, and the equation goes as y equals 5/9 times x minus 32. And we instantly see the graph on the right side. Second equation, we'll assign the variable y as Fahrenheit that depends on the values of Celsius x, and the equation goes as y equals 9/5x plus 32, and the graph as shown on the right side in color blue. These equation of the lines are actually in the form of y is equal to mx plus b, where m is the slope of the line. And as we see on both of these equations, The first equation is having a less than 1 slope value of m. That's why the graph shows more inclined to the horizontal axis, as opposed to the second equation, which is the slope of the line is greater than 1. So we expect that the line is inclined more on the vertical axis. And for graphing reference also, we plot the equation y is equal to x, means m slope of the line is equal to 1, which is at perfect 45-degree angle. And we can confirm, we can verify that the slope 5/9 on the first equation lies below this m is equal to 1 graph, and the slope 9/5 on the second equation lies above the m is equal to 1 graph. And as we can see on the graph, both of these lines intersect at x equals -40, y equals -40. So this is another way of finding out for what values of the temperature will the Celsius and Fahrenheit be of the same value. If you want to learn more on how this equation of the lines should behave on the graph, you can refer to the videos Graphs of Linear Equations. This is actually a fun bit of trivia, and it's a classic classroom example of solving equations with a practical purpose. So to summarize all of this, it is only in the extreme cold value of -40 that both the temperature scale, Celsius and Fahrenheit, have the same value. So the next time we encounter this kind of trivial question, we can easily give an answer right away. And if in case you forgot this remarkable number, -40, at least try to remember the freezing point and boiling point of water in Celsius and Fahrenheit. From here, we can derive any values corresponding to one another, even the equations for solving Celsius in terms of Fahrenheit and vice versa.